Another important topic regarding measure of spread is this idea, and it's a fundamental concept is, are we observing something unusual in the data? Something weird happening in the data that we've collected, or is there an observation that we're making that doesn't fit what normally happens? And so to do that, we have ways of measuring if something is unusual, meaning that it's far away from what we expect, which is usually the center. Unusual values are called outliers. So we use a z-score method or what's called the 1.5 times IQR rule. Now z-scores can sound technical, but this is a simple calculation. A z-score is a measure of how many standard deviations a value is from the mean. So it's measuring how far is it from the mean, but in standard deviations. So once we get those numbers, something's unusual if it's more than 2 standard deviations from the mean, meaning it could be unusually high or unusually low. And there's your formula to calculate the mean, a z-score. And again, you have these values. You'll have an x value, and you see, what is this x value? Is it unusual? Well, you subtract it from the mean and then divide that by the standard deviation, as you see in this first example. And you find out that in this case, that this value, this person who has 48 beats per minute, it's not an unusual value. Because we know the mean is 67.3 for adults and the standard deviation is 10.3 from data. That would be from data or sample data collected. You calculate the value at negative 1.87, and you can see kind of in this number line here, it's not unusual because it's not more than 2 standard deviations below or above, right? And that's that greenness there. Now you will see again on this example, again, computing z-scores. Z-scores are important, kind of like also a measure of location. It helps you measure how far you are away from average. Are you more above average? Are you more below average? And so in this example, being able to compare someone's GPA, even using 2 different measurements, one using GPAs and one using like percentages, you can see by calculating these, you can get z-scores. And in this case, we're trying to find out who has the highest, in this case here, we're looking which student has the highest GPA when compared to his school. And again, this is relative to his school, and that's what the data is. So you can see that this 2.85 is closer to the mean than the 77 because of the numbers. You get negative 0.21 and negative 0.3. So that 0.3 is farther away from the average, right, from the middle. So that's how we would check to see if something's unusual using z-scores. Now, the IQR method is a little bit more technical, and ArtaStat does does outliers for us. It's one of the choices you get in the ArtaStat. So coming back to the ArtaStat and showing an example, what I mean is, if you're choosing a dot box plot, and this was hours of children watching TV in 2018, you see you create a box plot. But what you also see in the ArtaStat, you will see here these little dots that go beyond the box. So these little dots would represent outliers, values that are farther away than the mean, right? The mean of 2.94 than we would expect. And so that's where the outliers occur in the ArtaStat when you use the exploring quantitative variables and put data in. There's outliers that will show up over there. Now we do spend a little time in this case doing some hand calculations, and what we calculate is what's called the upper fence and lower fence. Those values, right, because if we know those 2 numbers, then any value that lies beyond those, this is different than the 2 standard deviation rule because we're not using standard deviation here, we're using IQR. That's why it's a slightly different rule. We're using a different measure of spread. We find a lower and upper fence with these formulas here. Once you find these upper and lower formulas, we can then look at the data set, right? In this case, you get these 2 values. You get the IQR. Well, you can get the IQR from the data, and then you get these upper and lower fences. And the only number, 51 here, since it's bigger than 44.75, we would say that that is an outlier. It's unusually high. So this is a hand calculation that we would potentially ask you to do in an exam. Is determining something's an outlier that way. So looking at example 4 here, using z-score, right? Based on this situation, you can go ahead and calculate the z-score, right? Once you get a z-score, which is 1.78 below, that means he paid underneath the average price. We can calculate that, and then you can then say, okay, with that, we then know by going down 1.78 standard deviations, we get this value here, right? And that will then allow us, right, how much they paid based off of this amount, right, because of the z-score. Again, it's kind of a weirdly worded question, but allows you to think about the use of it and how we can use z-scores to help us with taking a look to see if something is unusual. Right? Here's a formula here that we can use here, this calculation above. The formula work. Again, this class is not focused on algebra, but if you have algebra skills, you could see how you could find that. You can find the x value once you know the standard deviation and the z-score and the mean. You can calculate x values in that way. We end this section. I'll post so you can read some of my stuff here. But you have a comparison between two service delivery food companies, and you can see that you have descriptive data, you have the box plots, you have dot plots, and then there's of course questions. Well, what is the explanatory? What are we doing while we're comparing? Explanatory variable would be the two service types. Delivery time is your response variable, because that's what we're comparing. And you can see it's complicated in that in this green one, service 2 has a smaller mean and median compared to this one, but there's a wide variability, meaning that this company takes a lot of time sometimes, and this one's pretty consistent, and that's where we got the answers to some of these questions here, where you can get these down and think about. And again, some of these are opinions, right? Would you be convinced if service 2 says we're faster than service 1? The answer is yes, but not all the time. Sometimes you take longer, but most of the time you are faster, right? Because you can compare the boxes there. And then you also have to think about, like in this question, would you be surprised if service 1 had a delivery time of 40 minutes? 40 is around here. That's about its max. So yeah, I wouldn't be surprised if it was 40 minutes. Not surprised if it's service 2. So which company is better, right? This is where statistics may not give us a definitive answer, but gives us information so that we can then make a decision based on what we think is important.